Okay, so 2 by 2 matrices, if you want to actually take the inverse of them, if in fact the inverse exists, not a big deal. In fact, the example we saw last time was I have A equals this matrix, and we saw its inverse equals that. And what was the recipe? The recipe is you take 1 over the determinant of this matrix, and then you take these two people and flip them, and then these two people you keep intact, but you just put negative signs in front of them. Now, what I want to do is to start to inspire a way of thinking about this procedure. It's a little bit different than what I just showed you, even though what I just showed you is perfectly fine. But the procedure I'm about to explain allows us to see how to generalize this to, in fact, larger size matrices, because this method, exactly as it is, will not carry over, for example, with 3 by 3. Okay, so what do you do here? Well, look at one way of thinking about this. I want to sort of describe to you how to find the inverse using a sort of well, in some sense, finding a determinesque kind of thing. Remember the determinants? How we found determinants with those pluses and minuses and stuff? So let me just show you a different way of finding the inverse. So we know this is the answer, and I'll come back to this and show you that, in fact, we get that. Now here's another way of getting the answer. Let's take this matrix, and let's make a new matrix. Let me call it N for new. And here's what I'm going to do. First thing I'm going to do is I'm going to put in those signs like we put in when we took determinants. Determinants of matrices. So we start off with a plus and then we alternate. So I put in a plus, minus, and then this would be a minus, plus. So I just alternate everywhere. Okay, now with those signs in place, I'm going to try to capture the spirit of the determinant in a way. Now watch what I do. For example, in the first spot here, all I'm going to do is get rid of that first spot and see what's left over and take that determinant. And that's just 5, so it's just 5. So I write a 5 in here. Now notice I'm not finding the determinant of a matrix now. I'm doing something different. If I were taking the determinant, remember I'd sort of multiply it by that term. But I'm doing something a little bit different now, so just sort of bear with me. I'm just blocking off everything, seeing what's left, taking the determinant of that, which in this case is just 5, and writing it in here. Let's do that now everywhere. So for example here, what I would do is what? I would get rid of everything that contains the 3, see what's left, which is a negative 1, and I'd write that in here. Now that's a negative negative 1, so I put a negative negative 1, will become a positive 1. What about here? Well, in this space I just block out that space here, see what's left, I get a 3. And what do I do here? I block out that space, I see a 1, and I write in a 1. So if you write this out, what I see is that this new matrix is the matrix 5 minus 1 is just a 1, minus 3, 1. Now, notice that that's actually pretty close to the actual inverse. Look at this matrix and look at that matrix. In fact, they're almost the same. What's the difference? The difference is sort of, I have to sort of flip along this diagonal. Do you see if I sort of flip that and put the 1 here and the minus 3 here? That's what this is. So if I take my new matrix and just flip it along the diagonal, what would I get? So let's take this answer and then just literally flip the numbers right along this axis. So these don't move at all. This number would go here and that number would go here. Well, then I have a newer number, and it would look like this. This diagonal stays the same, but now I've got a minus 3 there, and I've got a 1 here. And notice that matches up perfectly with this. So all I've got to do is put that 1 over the determinant in front, and I have the inverse. Let me recap what I did, because it seems so weird. What I did was, I first made a new matrix by putting the signs in alternating. So I have plus, minus, minus, plus. And then in this spot, to get that entry, what I did was I just blocked off the analogous spot here, saw what was left, and took a determinant. Didn't multiply it by 1 like you do with the determinant. I'm not finding a determinant now. I'm just finding that thing. And I write that number in. And I do that everywhere. Then I flip along this axis. I get this. And if I put 1 over the determinant, I get the inverse. This is a very strange way of finding the inverse here, because we already know that an easier way is just to do the thing I told you, to flip these two things and put negative signs there, and then 1 over the determinant. It turns out, though, that this weird way actually works in every single higher dimension. So the weird way is actually valuable. Let me recap. You put the sign chart in, alternating, plus, minus, minus, plus, fill it in. Once you do that, for each term here, all you do is block out the column and the row that represents that term. So in this case is the 1, 1 term. I block that out. See what's left, take a determinant if necessary, and write that answer right in here. Then just do that everywhere. Take the flip along this and put 1 over the determinant in front, and you've got the inverse. It's sort of an awkward thing to do, but actually it's a really easy way of taking determinants of big things. Little things, I think the easier way is just to do what I just told you about. So this is going to be a way of finding inverses using the similar kind of method we used to find determinants. We'll take a look at a 3 by 3 determinant and find its inverse of that matrix next. I'll see you there.